huge number. So this is a question to all of you really. How do you think technology has changed how we measure biodiversity over the years? Obviously, we've made hundreds of leaps in technology over the last 100 years. So what were the very early stages, before we had all this amazing computer technology and genetic analysis? What did people do to measure biodiversity to start, and how far have we come? Anyone want to have a go at that one?
I can start with that one. So, at first we were doing just like preservation, like how did Linnaeus and Darwin keep, document, because you could always illustrate something, but then if you had to go back and actually document it, keeping plants in herbarium and, pressing them, that was a pretty modern technique 200 years ago. And now we can do eDNA for obviously, as Rosetta was talking about, but also genomic sampling, which, you can look at the entirety of the DNA of an organism, which is just this incredible field. And it sometimes moves too far ahead before the traditional science can catch up. So there's lots of genomic work being done, but there's no specimen in a museum that's tied to it. So Saeed talked about, correcting the identification of something based on its genetics. We can't do that if we don't have a specimen in an herbarium or museum. So we need that connection between sort of traditional and traditional taxonomy and genomic work. And some of us, like me, tried to do both at the same time, maybe not always successfully, but yeah, that connection needs to be between old research or traditional research and modern tools needs to be strengthened.
I'd reiterate that strongly. Like, all the data that we derive from eDNA all comes back to having a reference sequence that we can identify that DNA sequence to. And essentially we want the information derived from taxonomists and the subsequent referencing sequencing of a sample to be able to have that. So I can't identify an unknown sequence unless I have a reference sequence, and that's normally derived by traditional methods. And it's really important. And as environmental DNA has kind of taken off in the last 10 years, a lot of the work that we're still trying to pull together is reliant on taxonomists supplying correct identifications of specimens and us then sequencing them so we can then identify them from eDNA. And that's really important that we kind of cross this kind of gap and have this kind of communication between the old and the new. But yeah, need them both.
Anything you'd like to add?
Yeah, I think the fellow panelists have said, it is very, very difficult to actually estimate what the species and what are the differences and what are available and what is the total estimate, because some articles mention that maybe we have about 8.7 million species of life living on Earth as at 2011. And as at 2020, we are saying that we have 15 million. But from my own research experience, I can tell you, I explore a particular species from different ecosystems of like 200 samples. And at the end of the day, I found out that all these species are the same thing. Now, how do we classify that where we want to estimate what are the total species on Earth? Which means that there are a lot of duplications in existence. There are a lot of misidentification in existence. There are a lot of overlaps. These very species, and of course, the basic and the most effective proven method so far as of now is the DNA technology, as it has been established. So we can confirm that this is the total species we have for plants. This is the total species we have for animals, and this is the ones that are available and this is the one that are not available. Thank you.
Great, thank you,
Thank you.
Sahid. So, and again,